Hello folks, I'm out here in the garage again and I'm getting ready to do yet another round of testing with the Harbor Freight Flux welder. Now this is their cheapest wire feed welder. This is the one that costs around $100 to $130. It used to be called a 90 amp flux core welder, now it's called a 125 amp welder. As far as I know, it's the same welder. They have the same specs list. They're both rated for 90 amp output at like 17 volts for 20% duty cycle. So they both have that same actual rated output of 90 amps, but the newer version that they call 125 amp version, they're just using the theoretical max output as the spec that they put on the box instead of the 90 amp rated output that they used to put on the box. Now for part 3, it's going to be somewhat of a continuation of my previous testing, but it's actually going to be a little bit more of just a start from scratch. Now, I know this welder is it's popular. A lot of people purchase this welder. A lot of people use it. So, I mean, I know that, anytime you talk about the capabilities of a welder like this, there's going to be, people that say, mine was better, mine was worse, whatever. But I just want to give, as accurate of a representation as possible of what this welder can do. And I'm not trying to knock the welder or anybody that buys it, anybody that uses it, anything like that. I really do just want to, just do testing and just see what the capabilities of this welder are. And so for this round of testing, I'm actually going to get maybe just a tiny bit more scientific about it. I'm going to weld up different thicknesses of material, and I'm actually going to cut and etch to see what kind of penetration I'm getting. I may still do some bend tests, some break tests, that kind of thing, but I'm going to test different thicknesses of wire. I'm just really going to try and see what I can get out of this machine, what this machine can do. And another big reason that this part is going to be quite a bit different is because my machine, and you can see it sitting here, it really did not like to run 035 wire. In the first video I did, I think I might have mentioned it, but definitely in the last video, part 2, I mentioned that it just really did not run 035 wire very well. And I did have somebody mention to me that they only run 035 in theirs. It runs great. Theirs has far and away more output power than what I was representing in the video. And it's a 120 volt AC output welder, so my expectations for it weren't completely and totally missed from the performance that I was getting. So it didn't immediately occur to me that there was anything wrong with it. But they're pretty convinced that there was something wrong with it, and I don't want to show testing and show results that people are going to use as a purchase decision based on a potentially defective machine. Now, unfortunately, since this welder only has a 90-day warranty, mine was well past the return date. So what I did is I actually went out and I bought another one. So for all the testing today, I'm going to be using this machine, the new machine, because I don't want to take a chance on spreading information that people are assuming is indicative of the machine and have it just unfortunately be based on a defective machine. In part 2, you had seen that this welder, my initial machine was model number 63583. And when I went to the store, they had multiples of both different model numbers on the shelf. So they had a bunch of this model number on the shelf, and this is actually a slightly different model number, and they had a bunch of these on the shelf as well. The box on the outside looks exactly the same. The only difference on the box outside is the model number. And if you can read it there, this one is 63582. Now, the surprising thing to me was that there was actually quite a few differences on the machine itself. Now, the spool system that holds the wire spool inside here is slightly different. I don't know that it's better or worse, but it is slightly different. There's also a couple of extra stickers inside this machine showing how to load the wire. The graphics on the front are slightly different. This one actually says Flux 125 versus this one just saying Flux welder. And the overtemp light is slightly different. It mostly seems to be cosmetic stuff. However, the big difference is actually the gun itself. Now, this is the gun on the new one that I just got, and it is quite a bit different. It's quite a bit larger. The trigger is quite a bit different compared to the previous one I got, which is this one here. So again, this is the gun that is on the model number that ends in 83, and this is the one on the model number that ends in 82. I don't know if one or the other is more recent or better or worse, or if they're just coming from different suppliers, but I just wanted to point out that there are actually some, at the very least, cosmetic differences between the two. But either way, I pretty much got this one set up. I have a roll of 035 Lincoln NR211 wire in here right now. That's what I'm going to start the testing with, just because I want to start right out with something that will pretty quickly give me an idea of if this machine is running just far different than the older machine. So if this machine is able to run the 035 wire a lot better, it seems like it's putting out a lot more heat, and I'm able to get a puddle going a lot quicker and stuff like that. That'll pretty quickly tell me that this machine's doing a lot better than the old one. But like I said, either way, I'm going to weld some different thickness materials. I'm going to cut and etch, check the penetration. I'm also going to hook up some meters on this machine, and I'm going to check and see what is the actual voltage and amperage that we can get out of this machine. And then from the cut and etching tests, we'll see how that translates into actual penetration performance on different materials. So hopefully in this video, we'll get to find out whether the performance is pretty much the same, and it just takes some tweaking and some dialing in to get the best results, and those results are going to be maybe consistent with what I've been getting so far. Or maybe we'll find out that there really was something wrong with this machine. Maybe it'll turn out that this machine just has far more power, welds better, smoother, just gets way better results, and in that case maybe this machine just has a problem with it and needs to be put down. So I'll start getting a few things set up, get some joints welded out, and we'll see how it does. Alright, so I did a little bit of testing to get things dialed in before I welded up this joint, and just observations so far, I don't think this new welder has any more power than the old one, or at least certainly nothing substantial. The one big thing I did notice being different is that I think the reason on the other welder why I couldn't turn the feed speed up very far at all before it started having issues is because I think that the knob speed isn't calibrated the same as the new one. On the old welder with 035 wire, if I turned the feed speed up above about 2, it would just sputter and pop, and it just ran terribly. You could tell that the arc would go out and the wire would just jam into the metal and try and push the gun away, and then it would light again and it would sputter, and it just basically wouldn't run at all with 035 wire above about a 2 wire feed speed. If I turned it down to like a 1, maybe 1.5, it would run okay, but the material would just pile up on the top, and it was just running super cold, and it just didn't run very well at all. So I found that putting an 030 wire in it and turning the wire feed speed up a lot more had it run a lot smoother, and that was the bulk of the welds that I tested were set up that way. With a new welder, I put 035 wire in it, and I just cranked it to the max right off the bat, put it right to 10, tried welding with it, and it was stuttering a little. The arc was going out a little bit. It was running about the way the other welder did when set to 2 on the wire feed speed. So I turned it back to about 9, and then it ran really smooth. And again, it ran about the way the other welder did on about a 1 or a 1.5. So I think the wire feed speed knob was just way off on the first one, or just all of the adjustment was between about 0 and 2. But either way, I welded this joint out a couple different ways, all with 035 wire. First I did 035 wire maxed out, and then I did one joint kind of fast, and then just to basically stay right at the leading edge of the puddle and not let things build up too much. And then I did another joint going pretty slow, but still with the welder set to max. I was taking notes and scribbling and stuff here, but this was done on the max setting, running slow with 035 wire, and you can see just piling up big time. Just a majorly crowned weld, big huge valleys on the toes at either side, and those valleys at the toes are going to be, it's almost like having a crack already there. It's basically a place for a crack to start. You don't want those big valleys like that. But either way, it's not laying down flat. Big crown, high crowned weld. Now with that setting, still 035 maxed, if I just went a little faster, just kept the wire right at the leading edge of the puddle, it ended up with a lot smaller weld, much smaller profile, but still just super crowned up. Just a really tall crowned bead. So then what I did, and I'm kind of smearing it a little bit, but I actually turned the welder down to speed 6 and ran slow, and you can see kind of a similar thing here, but not quite as crowned of a profile. Still, still some valleys on the toes, top and bottom. Still a pretty darn high crowned bead. You'd want to see it lay in a lot flatter, but it did lay in quite a bit flatter with the speed set to 6. Just so you know, this is 3/16 material here. And then finally, with the wire feed speed still set to 6, I ran a little faster. And again, just trying to keep that wire right at the front edge of the puddle. This little ball and this little lump at the end was just because I was running over a tack. But again, you can see still just a really high crowned profile. And you can even see the slag still kind of stuck down the toes because it's just a big V there. One reason I used this big T-joint like this is because for the last video, I just had tiny little coupons, and I actually arranged them like kind of corner to corner because that's where you're trying to put the heat into basically the edge of both pieces. Honestly, that's kind of a best case scenario. For this, I wanted to see a little bit more real world. What will it do on 3/16 material? So this is just 3/8 inch flat bar, 3/16 material arranged into a T-joint. So I'll get these all cut and etched, and we'll see what kind of actual penetration we got there. All right, I got the joints cut and etched, and I'll give you a look at them. First, we'll take a look at the joint that was run with the max wire feed speed and running pretty fast. And that's this one right here. And you can see there's not a ton of penetration, but there is some. There's a little bit of penetration on the bottom here. It did go all the way into the root, and there's a little bit on this top joint here. So even though this weld is a big crowned, it's not a great looking weld, but there was at least some penetration, some tie-in. And I think that just goes to the fact that I was trying to stay ahead of the puddle so that arc was able to drive right down into the root. Now it's kind of hard to see now that I've scratched it up, but right there is a tiny little hole, down at the very root. I might find if I cut this in a couple other places that there are some points where it doesn't quite get all the way down into the root. And then this was with the setting set at 6, and then it says fast travel speed, but obviously I didn't go quite as fast as I did here, so I didn't stay quite as well ahead of the puddle. It did end up with a larger bead, but you can see not nearly as much of just like a round crowned bead. It did lay in a little bit flatter, so I think that if I went just even a bit faster yet on this one, I might have gotten down into that root a little bit better, but it maybe not too, because it was set a lot lower. But on this one you can see almost no penetration, maybe just the tiniest bit right there. But right here it's pretty much just laying against the metal, and the entire base is just laying against the metal. So if you're going fast, you don't necessarily get a better looking weld with it maxed, but you do get what at least appears to be just a tiny bit better penetration. Although again, clearly I was going a little bit faster on this side. Now here's the two where I went slower, and on this side you have the side where I ran at max, and this side where I ran at number 6 on the wire feed speed. And it did run a little bit smoother on a wire feed speed of 6, but you can see I wasn't getting quite as much heat out of it now. On this side, with it run at max, only run slow, you can see that same just really tall bead profile. Only the difference here is that not even close to getting down into that root, and maybe a little bit of tie-in on this top side here, but very little down at the base here. Just, really hardly any tie-in down here. And on this side, where I was running at a feed of 7 and running slow, honestly, other than just a very slightly flatter bead profile, hardly any difference between these two. Neither one of these is going to be a super strong weld. I'm sure either one of these would break as easily as just about anything I've broken if I were to bend it. You always want there to be a radius in things. So, anytime you have a sharp 90-degree edge, that's a spot where a crack can start. It may hold okay for a lot of situations, but, if it's in an application where there's going to be a lot of stresses, a lot of back and forth loads over time, this sharp edge right here is where a crack could start a lot more easily than if this weld, kind of just ran straight across and didn't give you this sharp valley. So again, this one gave us the most penetration, but it's still not a great weld. I didn't cut and etch any of the welds with the other welder, but just based on how they broke and how they came apart, I'm not seeing hardly any difference with this welder in terms of the amount of performance that I'm getting out of it versus what I would expect. So I would say ultimate performance-wise, they're probably pretty similar. So anyway, that's how it did with 035 wire. I'll go ahead and switch to 030 wire now, and I'm going to set up another T-joint and weld out 4 little sections just like I did on this one, and just see how the penetration compares. All right, so I have another joint set up, pretty similar to the way I did the last one. This time I used 030 wire. I did the same kind of thing where I would run fast and slow travel speed, one time using the wire feed speed set at max, and once using the wire feed speed set at 7 on this one. With the 035 wire, it was set at about 6.5. This one I had it set at 7. This was with it maxed and running slow travel speed. This was with it set at 7 and running a fast travel speed. And on this side, this was with it maxed and running a fast travel speed. And this was with it set at 7 and running a pretty slow travel speed. So I'll get this one cut and etched as well, and we'll see how it did with the 030 wire. Alright, so now I have the two that are cut and etched that were done with 030 wire. First I have the one that was run fast. On this side I have the one that was set at the max wire feed speed of 10, and on this side it was set at 7. And honestly, neither one really got very much penetration. This side, you can see maybe it's just a little bit right there. On this side, maybe a little bit down towards the bottom. Just a little bit on this side, but really not very much either way. On both sides we have areas of lack of fusion, and neither side got right down into the root. And pretty much the same story with the slow travel speed. On this side we have it with a setting of 7. On this side we have a setting with max wire feed speed. And you can see really the only difference on this one is that on the setting of 7 you have a little bit less crowned of a bead. It went in, laid a lot flatter. You have a lot less of those big deep valleys here. Neither one of them got quite all the way into the root, and both of them have just very minimal penetration. And just as a reminder, with 035 wire, this was the best joint we got, to where just the teeniest little bit of tie-ins, and again just this really high crown with these deep valleys at the toes where it just gives it a place for a crack to start. So even with 035 wire feed speed set to the max, just very, very little penetration from this welder on 3/16 material. Now all of this welding was done with very little preheat. The only preheating that was involved was just the fact that the part heated up a little bit just because I kept doing the welds, but I didn't do them all back to back. I let at least a couple minutes pass between each one so that the part wouldn't just get scalding hot, because then otherwise the last couple welds would seem to have a lot more penetration than the first couple, just because they were going into so much hotter of a part. But either way, 030, 035, different travel speeds, different wire feed speeds, these are the best results I got. Now I will move on and test some 1/8 inch material to see what kind of penetration I get on that, and I'm also going to test another welder just to show some point of comparison. But I did test the output of this machine. It does hit the specs that it claims, and I'll show the readings on the screen here that I was able to get. I did these tests with 035 wire. First I tested with the machine just absolutely maxed out. I actually got over what they say the maximum amperage output is. It was showing close to like 140 amps. The voltage was pretty low at only about 15, bouncing around to maybe as high as 16 volts. That's pretty good. Now if I turn the wire feed speed down just a little bit to where it wasn't stuttering and popping and stuff, because it with that wire feed speed maxed on 035 wire, it does start to stutter a little bit. It doesn't run very smooth. If I turn the wire feed speed down just a little bit to about 7 or so with the 035 wire, that's where I was getting almost exactly the max rated amperage of about 120 to 125 amps, and the voltage came right up and it was running like 17 volts. So voltage and amperage within spec, it's definitely putting out what it should. Again, this is the new machine, and so these results are all with that machine putting out what it says it can do and then some. In fact, just bear in mind, this weld was actually with the machine putting out about 140 amps and about 16 volts. But one of the reasons why you just get such crowned beads, such minimal penetration, such poor power output, considering you're putting 140 amps into this part at those voltages, you would think you'd get a lot better results. And I think it's just the AC output that's really holding it back. Because you have alternating current and you have the voltage, cycling back between positive and negative, 60 times a second, basically half of the time the voltage is the opposite of the polarity that Flux core prefers to run at. So that just really limits your output. So basically, despite the fact that this welder is actually putting out even more than what it's rated for, you're still not going to get as much power and penetration out of it as you would a DC welder that was running 125, 140 amps. So just bear in mind that is one thing that is affecting the output of this beyond just the rating, because as I showed there, the machine is putting out at or above the rated capacity. Alright, so just as a point of comparison, here is a joint I welded up with a different welder. Now it's a dual voltage machine. I had it running on 120 volts, and I had the output adjusted to give me 16.5 volts at about 130 to 140 amps. Pretty close to what I was getting out of the Harbor Freight machine maxed out. You know, it's as close to apples as I can get in terms of the output of the Harbor Freight machine compared to a similar output on another machine. The difference being that the other machine was running DC electrode negative, which is what Flux core runs better on. And just to give you an idea of just how much difference that makes, here is the joint, and you can see very, very flat. You know, the joint profile laid in there nice and flat. You don't have that big crowned up weld with the big V's and valleys on the sides. Just went a lot smoother, less spatter. It just lays in there so much nicer when you have DC output. And in terms of penetration, you can see quite a bit of penetration on the bottom, plenty of penetration on this upright portion. Got all the way down into the root. You know, if you kind of draw a line there, it's well down into that the root of that joint. So again, you know, different welder running basically the same total output, but it is DC output versus the AC output that you get with the Harbor Freight machine. All right, one final comparison, and then we'll move on. Now, I did another joint here with yet a third welder, just in case you were thinking, oh, well, he used a dual voltage machine, it's way more expensive or whatever. I did this with one of the least expensive DC capable welders out there, and this machine is actually rated at, it says an 80 amp rated, 90 amp max. So this welder is putting out a lot less total amperage than the Harbor Freight machine, but it is a DC output. And so you can see once again, even with the lower output, a very flat bead profile. I mean, just super flat, laid in there nice and smooth. But you can see here, even with only 90 amps of output max, we still are doing better than the Harbor Freight welder. Not as much as the other machine, but again, this unit is only giving 90 amps of output. With 90 amps of DC, we get a nice flat profile without those valleys at the toes that are going to, you know, be a spot where a crack could start. Again, it does have a tiny little hole down at the root, but good penetration along both sides. And again, compared to the very best from the Harbor Freight welder, you know, where the Harbor Freight welder was putting out 140 amps, you know, you can see just the really flat versus the high crown bead. You know, there was some penetration on the weld from the Harbor Freight welder, but really no more than there was here. Maybe, you know, maybe even a little bit less in some spots. And it's a smaller weld overall. You know, if you take the distance from here to here, you know, you have a lot longer weld leg size here on this weld. You know, despite not having huge areas with no tie-in. You know, again, just the fact that this is an AC output is really, really holding it back, because, you know, we are getting 140 amps output at this weld, and it just really doesn't seem to show it with the amount of performance you get. And because I'm sure people will ask, that last weld was done with this welder. It's the Century FC90. I just picked it up. That was literally the first weld I made with it, and I picked this up at Home Depot. I've been wanting to review it for a while just because, like I said, it is one of the least expensive DC output flux core welders that I could find. So I'll probably be doing some more testing with this in the future, and maybe do a review on it. But either way, that's the welder I used for that last test. And it has what they call an 80 amp rated output with a 30% duty cycle and a max of 90 amps, and they don't give the duty cycle on at 90. Alright, so now I welded a T-joint on some 1/8 inch material with the Harbor Freight flux core welder, and I went ahead and cut and etched it, and let's take a look at what we got here. So I actually welded this side first, and then I just unclamped the part, spun it around, and then welded the other side. I did not let it cool at all. So this side was done with the part already heated up from having welded that side. So on this side you can see very, very little penetration here, but the line isn't perfectly straight across. It's got a little bit of a belly to it, so I think it is tied in on the base, just not a whole lot. But I don't see like a major lack of fusion there. And then on this vertical member, you know, it is tied in pretty decent now. There still is a little bit of a spot right here at the very root of the joint that I'm not positive is tied in real well. Yeah, I guess if I look at it from there, I can see there is a tiny bit of a hole there. So not quite all the way into the root of the joint, but definitely tied in. So on the non-preheated part, this is what we got. Then I moved over to the other side, and it did go in a lot better on that side. You can see not quite as much crown to the weld. These ones here, they're tied in right to the toes, and there's no right angles going on there. And on this one, much more noticeable penetration down here on the bottom, some definite penetration here on the side, and this one does seem like it went all the way into that root. But again, this is 1/8 inch material with the machine maxed out, non-preheated part, and then a part that was warm from the first weld going in. All right, and just so we can get kind of an apples to apples comparison with the testing I did with the other welder, I went ahead and welded up a small joint of the 3/16 material, and I'm going to go ahead and bend it just like I did the other ones and see how it goes. Again, welded up with the new Harbor Freight welder, 035 wire maxed out. Alright, and this thing is still pretty hot from welding. I actually didn't really let it cool. You can see it actually did about as well as the one that I preheated with the other welder. You can see it was just starting to kind of bend the material over a little bit. Even on this side it did bend a little bit. But if you look in here, you can see pretty much the same story we saw before. On this end you can see just a huge area where there's no tie-in at all. You can see just kind of the shiny bottom of the weld where there was a spot where it was just completely flat because it was just sitting on the base metal and didn't really tie in at all. And again, over here at the end, you can see a line right there where, there was a spot where there was no tie-in, down at the root, just along the end. So maybe just a tiny bit better than we got with the other welder without preheating, but not a huge difference. And now keep in mind, it's not really that surprising when a weld breaks when bent in that direction. Compressing that weld like that, is kind of the worst case scenario for an inside corner joint. It's stronger in the other direction. I just bent the other ones that way to highlight the differences between the different methods, like you saw before, whether it's preheating or not, or multi-pass or whatever. So really, I just wanted to do this for as close to an apples to apples comparison with the old welder as I could. And you can see maybe just a tiny bit better on this welder, running 035 wire and just maxed out versus the other welder, which was running 030 wire and as hot as I could get it to run. Obviously, this welder isn't drastically more powerful than the other one. I don't think there was any defect with the first Harbor Freight welder I had that was causing it to have just massively low output or anything like that. I do think that there might have been something odd going on with that wire speed adjustment, just because it did get too fast for 035 wire. It just hardly turned up at all. And even with 030 wire, I couldn't turn it up as high as this one on the feed speed before it started having issues. But having said that, I don't think that was because the output was low. I think that was just because the knob was giving me more wire feed speed for a given setting with the first welder. So I don't think that it was actually limiting output. I think it was just making it harder to set. Having said that, of the two, I do think this is the better welder, the second one. The gun itself is a little bit larger. It has a higher amperage rating number on it. It says it's a 200 amp gun. The other one says 150 amps. I don't really think either one of them would be a problem in that respect. But I do think that the cable on this one is a little bit better. Really hardly any different at all, but this one just seems like it's a little bit more flexible, whereas this wrap on the outside almost seemed like shrink wrap that was shrunk tight around the other one, so it made it a little bit less flexible. And also the fan on this one is a lot quieter. It's a lot smoother fan. It really doesn't cause a lot of vibration or anything. Whereas with the other machine, the fan actually caused a ton of vibration. I don't think it was balanced very well, and the whole machine rattled while it was running. So that was kind of annoying, and this one doesn't do that at all. The fan's really smooth. So again, overall, I do think this is the better machine, but I think, output-wise, no major difference between the two. And honestly, just that issue with not being able to turn the wire feed speed up at all just made me question the first machine enough that I thought, you know what, I'm going to get a second one just to be sure. But to be perfectly honest, I didn't really expect a drastic difference in the power, just because the simple fact is it's a 120 volt machine with AC output. So, there's just going to be limitations to that. Now, that doesn't make it a bad welder. It's a very simple design. I mean, just a transformer with a contactor that pulls in to initiate the welding current. Very simple machine, probably pretty robust, probably pretty durable, hold up pretty well over time. Sure, it's low cost, but there's not a lot to it, so there's not really a lot to go wrong. And also, in all my welding, not that I ever did just one continuous really long run, but there was a lot of times where I was just putting pass after pass after pass in on different pieces with only enough time to grab the wire wheel, wire off the slag, and then put more passes down. And I was doing that for a little while, and I never hit over temp. The machine never acted up or anything. So again, it's probably a pretty durable welder. I can understand why people like it. It's inexpensive. It's reliable. It's durable. But the simple fact is the output is limited just due to the fact that it's 120 volts with AC output. And, the AC output I think is the big killer on this one. And, so that's really all I wanted to get across in this video is just what the capabilities of this machine are, what the limitations of it are, and what you can expect to get out of it if you do want to pick one up. I think for 1/8 inch and under material it does fine. On 3/16 material, for certain joint configurations, or if you can do multi-pass, that kind of thing, I think it can do okay. But just bear in mind, you're really not going to get a ton of penetration on 3/16. Now, there are people who have modified these machines to actually make them DC output, and it's really just a matter of ordering some components online. You can get things from eBay and DigiKey and that kind of thing, and really you just need to put a rectifier circuit in that is capable of the amperage output that this machine can do. Now, if you're comfortable doing something like that or taking a project like that on and you already have one of these welders, it might not be a bad option to look into. Now, in terms of buying one of these welders with the intention of doing that, maybe a little bit less value in doing that because you have to buy the welder, factor in that cost, and factor in ordering the components, tearing the thing apart, doing it yourself, and you'd have to weigh that versus just buying a little bit more expensive machine. But either way, I think that's going to do it for now for this video. I did have some other ideas for stuff I was kind of thinking I would try, but since this welder is essentially putting out about the same amount of power as the other one, there's not a lot of reason to keep belaboring the point to see if it'll do better than the last one. But I still have the welder, in fact 2 of them now, so if there is any specific project or specific type of joint or specific thickness or anything that you want to see with this welder, to see me try and see what kind of results I can get out of it, just post it up down below, and if I can, I'll do it. But for now, hopefully you got something out of this video. Hopefully it was helpful to somebody that's considering this machine, or kind of had questions about how my last machine was running, since it wouldn't run 035 very well. And again, I think, like I said, I think it mostly came down to just that odd adjustment ratio with the wire feed speed, where it just seemed like that adjustment was just really stacked up down towards the bottom. And also, I kind of almost suspected that the liner in the gun was maybe just partly kinked or something, to where with the larger wire it was causing feed irregularities or something like that. I don't know that that was for sure the thing, but it could have been something like that. But like I said, this machine maxed out with 035 wire didn't run that much different than the other machine did at about a setting of 2 or so with 035 wire. But anyway, that does it for now. If you have any questions, post them up down below. And as always, thank you for watching. Take care.